Have you ever been studying for an exam and felt like this?
Please help me.
If so, you've come to the right place. Dr. Perkins is here to help you. With tips and explanations that will not just help you learn the information, but master it for years to come. Alright guys, welcome back. Today we're going to be talking about excitation, contraction, coupling. Alright, so what is that and why do we care? Well, what happens is excitation. The muscle gets excited, right? And because the muscle's excited, it's going to contract, right? The muscle's going to get shorter, and that's what lets us lift things up. That's what it is in a nutshell. All right, so what are the fine details? So the brain says, you know what? Time to show off my muscles. And so here's a motor neuron, and this tells the muscle, contract, right? And so what's happening is this action going down the motor neuron, and when the action potential gets over here at the end of the neuron, right? What happens is you got calcium that floods into this neuron right here. So we got all this calcium flooding into this neuron because this neuron has voltage-gated calcium channels. All right, and so what that's going to do is that's going to stimulate these vesicles right here to dump their acetylcholine. And so now I'm dumping my acetylcholine, and it's going across the synapse. So the synapse is this small little gap here, right? And that's going to separate the motor neuron and the muscle cell, right? And so this gap is extremely small. We're talking about 50 nanometers. To give you an idea what a nanometer is, take a meter, chop it into a billion pieces, and just take one. That's a nanometer. So for this gap, you would take 50 of those little pieces. So itty bitty microscopic. And so we're releasing all this acetylcholine right here. And so this acetylcholine is going to bind to these receptors. And so what that's then going to do is it's going to trigger this cell over here, this muscle cell, to release sodium. And so what's going to happen is the sodium is getting released into this muscle cell, right? Because whenever the acetylcholine binds to the acetylcholine receptors, we're releasing sodium into the muscle cell. Uh-oh, and it looks like I forgot to draw a acetylcholine receptor. All right, but we're releasing sodium into this muscle cell. And so what's going to happen is this muscle cell, is normally at negative 90 millivolts. So it's more negative on the inside than on the outside. But what will then happen is as we open up more and more of these voltage-gated sodium channels, more and more of these acetylcholine-gated sodium channels, sodium's flooding into the cell. Well, sodium's positive. And so when this becomes more positive than negative, depending on who you read, 55 to negative 50 millivolts, something very important happens. What happens is you have voltage-gated sodium channels. And so this is going to allow sodium to enter the cell outside of that acetylcholine receptor. Well, what happens? Now, this part of the cell is becoming more positive as that sodium spreads out. Now, these channels are going to be just like a door. They're going to be open, close, that fast, right? You know, depending on who you read, it's about 1/1000th of a second or 1 millisecond. And so what's going to happen is as that positive charge spreads out, it's going to trigger the next one to open, and the next one to open, and the next one to open, right? And so you see how these voltage-gated sodium channels are causing sodium to spread out across that cell membrane, because each one that opens triggers the next one to open. All right. Now, it's also happening over here as well, that we're opening up these voltage-gated sodium channels. Now, as we get over here, we have something called a T-tubule or a transverse tubule. And so this is going to transverse, it's going to go across the muscle cell. And so we're going deep down into the muscle cell where these muscle fibers are. And that's what's going to allow us to contract or relax. Well, your muscle cells they're not allowed to contract all the time. And the reason being is they got this protein that stops these muscle fibers, actin and myosin, from being able to contract, to be able to talk to each other. All right, and so what we need to do for them to be able to contract is we need to release calcium. All right, and so what's going to happen is when we get over here, our voltage-gated calcium channels are going to open up. And so it's opening up and we're allowing calcium into the cell. And so just for the sake of clarity, simplicity, I'm just drawing arrows to speed this along. And so now we got all this calcium entering into this cell right here, right? And it's spreading out in all directions. All right, so what's happened is now this is pretty positive on the inside of the cell. And now it's going to trigger the sarcoplasmic reticulum over here to release its calcium. And so we're releasing calcium, right? We don't care too much about the calcium going this way. What's really going to be important is when the calcium goes this way, when it goes to those muscle fibers. All right, and that's going to be very, very important. So we got this calcium going over here to our muscle fibers, and now we're going into the next phase of our muscle contraction. So all of this right here was the latent phase, right? And so at this point in time, you've had absolutely no muscle shortening, no response whatsoever. What's going to happen in the next phase is the contraction phase. So what's happened is we got all this calcium being released right here, right, because of our excitation. And so what's going to happen is some of this calcium is going to bind to troponin. And so troponin has a good buddy called tropomyosin. And where troponin goes, tropomyosin goes. And so when troponin binds to calcium, it changes shape. And so because troponin changes shape, it's going to force this tropomyosin to change shape. So what you notice is all these little black dots that are being hidden by my tropomyosin, right? And so those are the myosin binding sites. So this is where myosin is going to want to bind, right? So what happens when myosin binds to actin? Well, here we go. I drew it down here. And so we got myosin. It has basically ATP attached to it. And so now it can bind to that troponin. And it can bind to that actin. And so what's going to happen here is it's going to click, right? It's going to cock right here. So you notice my wrist went from here to click right here, right? It curled. What that's going to do is going to pull the actin right here. And so my muscle is going to shorten right there because we're pulling it. What happens is I got another ATP that will now bind to take the place of the ATP that split over here, right? When the ATP splits, that's what's causing the myosin to bend right here. That's what's going to shorten that actin, right? But when I get my next ATP here, right, it causes my myosin head, instead of being like this, to cock back. It also causes it to release from that actin. And so now, because I have that ATP here, I can bind further on up. And so you see, each time I go through the cycle, what happens? I move further on down, right? The cycle just repeats. And so I'm pulling this actin more and more this way, right? Now, why doesn't the actin just slide all the way back? Well, because I just don't have one myosin head, right? I have hundreds of myosin heads. And so while this one lets go, the other one holds onto it, right? It's like when I'm doing that tug of war. What happens? I pull the rope here, right? And then I grab over here. So I can let go with this hand, and while I'm pulling over here, I can grab up here, right? And so that's how I can pull the rope towards me, is by constantly letting go with the one hand and grabbing on with the next, right? If I let go of both hands at the same time, if all the myosin heads were to let go at the same time, the rope would just slide over here, right? The muscle would relax, all right? So that's what's happening in that excitation contraction coupling. You can think of the troponin and tropomyosin kind of, let's say you and your wife want to get a romantic weekend to rekindle the romance, right? Well, you and your wife want to interact, but you can't because the kid's like, Bob, what are you doing? This movie's so boring, right? Not going to work so good. So you need to get the kids out of the way, right? So how are you going to get the kids out of the way? Well, you have grandma come for a visit, and she has a movie that she could get the kids interested in watching. And so while the movie's there, grandma's got the kids interested in it, and the kids are out of the way, and so you and your husband or your wife can have a romantic weekend. But what happens when the movie's all done? Well, the kids aren't so interested in grandma anymore, and they come and try to hang out with you guys. Mom, what are you guys doing? We're watching a romantic movie, right? Date night's all done now, right? Why? Because now, once again, they're kind of blocking those binding sites, right? You don't necessarily want to be snuggling your wife with all the kids watching. Same idea right here, right? When that tropomyosin slides back in the way because calcium's all gone, because we pumped it back into that sarcoplasmic reticulum, right? It blocks the myosin binding sites on the actin, and so now the actin can't do this, right? It can't do this anymore. And so as a result, it lets go of the rope, it lets go of that actin, and it slides back, and that muscle relaxes.